Welcome everybody to our final business math class. So those of you, some of you will take, I forget if is statistics mandatory? Do you have to take statistics at APU? Or if you're an APM student? I forget. Anyway, some of you will take statistics. And I just want to invite you to also think about taking data mining and another course called Information Science Lab that are, I think, very useful for your future. I think that these days data mining and information science is really important, and we have some good courses that I'm teaching. So, if you're interested, please don't hesitate to take them. Okay, anyway, we have one last topic to cover, and that's elasticity. But let's talk about the final exam first. So I told you before that the final exam would cover every assignment that we did, but I decided to reduce it a little bit. So if you go to communication here, and you click on this, you'll see reduction in material needed to study for the final exam. And these homework section parts are not included in the final exam, so you don't need to review these. Okay, so chapter 0, week 2, chapter 1, section 1, week 2, chapter 1, limits, continuity, average rate of change, and derivatives part 1. So you don't need to review that material for the exam. I mean, of course you can, but I won't include questions from there in the final exam. Okay, is that clear? This is in the communication, you can just find that. Right? Okay. So, it says right here, reduction in material. Okay? So, other than that though, the other sections can be included. So, like elasticity, there's a problem in elasticity. There's one in definite integrals, there's one in integrals by substitution. There's one in indefinite integrals, there's one in sketching, there's one in higher order derivatives, there's one here. By the way, there's nothing here, I don't do this one. And I'm sorry, I forgot to say, I'm not going to test her in this one either. So, implicit differentiation you don't need to do. Okay? I think there's one from here, and I think there's one from here. There might be one from the chain rule. There could be some, there's one from marginal cost. I think there's one from, elasticity. So that's like all the derivative stuff basically. Plus, there's stuff on annuities, compound interest, and simple interest, and a few of these things here, like certain kinds of models. Okay, so it's not that much material, actually, and I tried actually to only ask you problems from the beginning of each homework set, but there's one that's not true about. Which one was that? That was, I think, what was that? It was here, or here. It was here. Let's see. Oops. I think I asked you from here things throughout this. Other than that, I think most of them are from the beginning. But yeah, this one I didn't I might ask you stuff that's not just from the beginning of this homework set. So it could be these as well. Okay? But generally I try to stay around here when I ask you questions. Okay? You know what I'm talking about? Okay. Any questions? So there's one topic we haven't covered, and that's called elasticity. So we have to cover that today, and that will be there will be a question on that on the exam. Okay, so let's do that. If there are no questions, anybody have any? Oh, no calculators, no paper, no phone, no dictionary, only pencil and pen and eraser. Okay? That's all. Some of the problems, I said, just give me the formula, don't do the calculation, because the calculation would be messy. So then in that case, I said, just give me the formula, and then also give me, fill in the numbers into the formula, but don't do the calculation itself. So in that case, you don't have to do any difficult calculations. Okay? Okay, so anybody have any questions before we go to elasticity? Okay, so let's look at. I thought this was. Oh, let's look at. Now I know everybody's preparing for the Japanese exam, which is probably tomorrow, right? Or soon? When? I mean Thursday, I'm sorry, day after tomorrow. So, what's this word? By the way, do we have any Japanese students in our class? Anybody Japanese here? Expert in Japanese? No. Okay, anyway, so what's this? Dan-myoku-sei. Dan-myoku-sei. So, does anybody recognize any of these kanji? I recognize yoku. It's like a power, or something like that, right? Chikara, like that. And the sei is what? Is it the same sensei? Sensei no sei? No? What is this sei? Dansei no sei, okay. Okay, dansei no sei. And what about dan? Does anybody know what that means? No? Okay, so anyway, dan ryoku sei. So what does that mean? I guess it means elasticity, right? And what does elasticity mean? What does elasticity mean? What do you think of when you think of the word elasticity? Like something stretching, right? Yeah. So when I think of elasticity, though, I think the way they use elasticity in economics, we're learning about that, and that's what we're talking about today. When they use that word, I don't think they use it the way we normally think of elasticity. So I wish they hadn't used that word. Because what does elasticity mean? What does elasticity mean to you? So to me it's like if you squeeze a ball, it comes back, it springs back. Or if you pull on a bow and arrow, you pull, it comes back. That's the elastic part. Coming back is kind of the elastic part as far as I'm concerned. How about, whatever it is, like a bed. you push on the bed, you push it comes back, right? That's elastic. So like if you push on something and it moves, and then it doesn't come back, do you call that elastic or not? I don't think I call that elastic, right? So it's the part of that it comes back that is the elastic, but that's not what they really mean in when we do it in economics. So I wish they hadn't used this word. Okay, so what does it? Does anybody know? Anybody use this in economics at all? Ever heard that word in economics before? Any, what? Price elasticity. Right. Okay, yeah. How do you do that, by the way? How do you say that in Japanese? How do you say price elasticity? Kakaku, what? Danryokusei, right? Kakaku danryokusei. Okay? That's kakaku, right? Is price, right? I guess. So, price elasticity, yeah. That, I think, has anybody else heard that from in economics? Okay? And how about this? How about that? Elasticity of demand. So, how do you say that in Japanese? How do you pronounce this? Juyo? Or Juyo? Juyo, it says Juyo, I guess. Juyo no danryokusei. Okay, so that's what? So this is, demand must be Juyo, right? Juyo no danryokusei. Okay, so does anybody know what that means in economics? Any idea of what it means? What does it mean?
The response of demand to changing price.
Ah, okay. Okay. So did you hear what he said? He said the response of demand to a change in the price. What does that mean? The response of demand to a change in price. What's that mean? I should have typed it. How do you say that? Kakaku no henka ni taisuru juyo no anno. That make sense to anybody? Okay, so what does that mean? The response of demand to a change in price. So what are we're talking about what? When we change the price, right, of something, let's talk about something specific. Let's say we have coffee. Okay, so we have coffee beans. So we can talk about the demand curve for coffee, right? So what does the demand curve look like again? That we've already discussed. What is the demand curve? So not all books put P there, but some books put P there and Q here. Some books write it the other way around. But I'll just put it that way. So what does the demand curve look like? Does it look like this way or that way? A or B? Looks like A, right? What do we mean by it looks like A? We mean it's decreasing, right? Why do we say it's decreasing? Why do we say it's decreasing? Because as the price increases, what happens to the demand? It decreases, right? So it's decreasing, right? And okay, so now going back to this phrase, the response of demand to a change in price. So what does that mean? That means like if I change the price from, say, 10 to 15, right? Let's say we have 10 and 15, we get what? Here we had this quantity was demanded, and here we have this quantity was demanded. So there was a decrease in the demand, right? Or the increase in price, right? So there was a change in demand in response to a change in price, right? Does everyone understand that? So this idea, the response of demand to a change in price, is talking about this. And this is also called the price elasticity of demand. Okay, because price, we're talking about changing the price. Okay, then we see what happens to demand. Okay, so it's called the price elasticity of demand. Okay, is this clear? How do you say that in Japanese? Juyo no kakaku danryokusei. Okay? So, how should we measure this responsiveness? Oh, so I wanted to say that someone said it was the response, but they used the word elasticity. And I don't think we should use the word elasticity, I think we should use the word response. Because the idea is, okay, so when we talk about elasticity, like when you pull on a bow and arrow, right, you're exerting a force, right? Right? And when you exert that force, it moves. And we're saying something similar here. What we're going to get a response, right? What's the response we're talking about? The reduction in demand, or it could be the increase in demand. But the change in the demand, right? That's the response that we're talking about, right? There's no elasticity, right? We're not talking about it going back. Right? There's no reason to use the word elasticity as far as I know. Now I'm recording this, so I'm a little bit shy to make this claim because I'm not sure, but it seems to me that that's true. That there's no elasticity, no concept of elasticity here. We're just measuring the response, right? Okay? We're just measuring how much movement. So the idea is if you have a really stiff, I'm talking about a bow and arrow. If you have a really stiff bow, right? Or maybe stiff string? No, stiff bow. And if you pull a lot on it, it doesn't move, right? But if you have like a elastic bow or a flexible bow, and you pull on it, you get more movement, right? And the same thing, we're interested in the same kind of thing here. We're wondering how much movement you're going to get by pulling on the bow, or how much movement we're going to get in demand, right? Now what do we mean by pulling? What's the analogy to pulling in this situation? What's the analogy? So the movement is the change in quantity, right? The movement of the bow is analogous to the change in the quantity. And what's the analogy for the pulling of the bow? That's the force we're applying on the bow. What are we saying here? To get the same response, we're changing the price. So that's the force. Changing the price is the force. It's the analogous situation, right? Okay, so when we talk about what kind of response we get when we pull the bow, we're talking about what kind of response we get when we change the price. Okay, so pulling the boat, changing the price of this are similar in this sense. Okay? So does everyone understand? So that's why I don't understand why they use the word elasticity. I would have used the word response, or something like that, not elasticity. But anyway, I'm not going to change the world. That's what they use, elasticity. Okay, so now, what else? How do we measure this? We want to talk about, or even if we don't measure it, how much, let's say this is 1,000, and this is 800. Okay? So when we change the price from 10 to 15, let's say dollars, okay, for coffee, let's say it's for a kilogram of coffee. Okay? The demand went from where to where? From 1,000 to 800, right? And how much change was there in the price? $5, right? Now, suppose we did it over here. Suppose this is what? 20, 25, 30 to 35. Okay? So then we have here, which is about what? This scale is not too good, right? Let's say this is 300. It's not good, but... And let's say this is 250. Okay? This is not drawn very well, but still let me just do that. Okay? So now, when we change the price from what to what? When we change the price from 30 to 35, we increase again by how much? How much did we increase? By $5. And what change in quantity did we get here? 50. Right? The demand dropped by 50. Okay? Everyone get it? So there's a difference between what happens here and what happens here. What's the difference? What? Yeah, you get less change over here. For the same increase in price, you get less change here than you do over here. Now, I just drew this graph arbitrarily, right? I could have drawn it some other way, and maybe it would have been just the opposite, or whatever, right? I just happened to draw it this way. Like, if I had drawn it this way, now what? Would we get different changes for the same change in the price? Would you get a different change? No. You get the same change, right? Right? If you change by $5 from here to here, you're going to get the same drop as you do if you change by $5 from here to here, right? So, everyone agree with that? Okay? But on the other hand, if the demand curve looked like this, then it's what we said before. Okay? So, we don't know what the demand curve is for coffee, and whatever it is for coffee is going to be different for tea, and whatever it is for tea, it's going to be different than it is for beans, and whatever it is for beans, it's going to be different than it is for iPhones. Right? So it's different. They're all different shapes. We don't know what they look like. But anyway, we can still talk about this kind of change. We're talking about the change in the quantity relative to the change in the price. Right? And how do we write that in math? When I said relative, right? Relative means quotient or ratio. Right? So the change in the quantity relative to the change in price means what? Change in quantity divided by change in price, which is also known as the slope, right? It's also known as the slope, right? So what we're talking about this is what we mean by elasticity, basically. This, not exactly this, but basically this is what we mean by elasticity. And graphically, so therefore, what can you say graphically, what do we mean by elasticity? geometrically, what do we mean by it? We mean slope, right? So elasticity is the change, the response in the change of the quantity when you change the price, but graphically, it's what? It's the slope, right? So we often want to, go from a concept we have in reality and sort of try and figure out how is that, if we're looking at a graph, how is that related, or where does that show up in the graph? So then we can start using the graph more effectively, right? Anyway, so the situation here is we get the slope, right? So what we're saying is this slope is greater than this slope, right? And therefore, the elasticity here is greater than the elasticity here. That makes sense? Okay. Now, okay, so what is the elasticity here? If this is the definition of if this were the definition of elasticity, we're going to change it a little bit because I'm going to point out one problem with this. But if this were the definition of elasticity, what would be the elasticity here? It would be 50, right? 50. That's 300 minus 250, which is 50, over 5, right? And she said it was 10. That's right, it was 10. Now, one thing is that actually it's negative, right? Negative 10, right? So it's that, right? Because we'd have to do 30 minus 35, and also because the slope is negative, right? The slope is negative here, right? It's not positive, it's negative, right? So the elasticity here is negative tension, okay? And how about here? What is it? 200 over minus 5, which is negative 40, right? So we say the elasticity is greater here than here. Okay? Now they don't want the elasticity to be a negative number for whatever, just not convenient to make it negative. So they define elasticity not to be this, but to be this. Okay, now it's not going to be negative, right? So the elasticity here will be what? 40, and the elasticity here will be 10. So not negative anymore. Okay, so we'll do that. And there's still one more problem here, and that is, if I'm talking about coffee, and suppose this was really the real picture for coffee, suppose this was the true demand curve for coffee. So we just said that when the price was here, we get a kind of an elasticity of about 40, and here we get an elasticity about 10, right? And that's supposed to tell us something about the way people are behaving towards coffee, right? That's supposed to tell us something about the way people are behaving towards coffee. So it shouldn't matter whether I measure the price in dollars or in pennies. It shouldn't matter whether I measure the price in dollars or pennies, because it's supposed to be telling me about the way people behave, and it's not supposed to be dependent on the units that I use to measure it. Or put it this way, they want it to be independent of the units that we use to measure it. Okay, whether it should or not, doesn't matter. That's what they want it to be, independent of the units that we measure. But this will not be independent of the units that we measured it. For example, we just said that we said what was the demand here? I'm sorry, what was the elasticity here? 10. That was when we measured the price of coffee in dollars. Suppose we change it to pennies. So instead of $10, what do we have to write? 1,000 pennies, right? I'm sorry, instead of $30, what do we have to write? Sorry. instead of $30, what do we have to write? 3,000 pennies. And instead of $35, what do we have to write? 3,500 pennies. So when we subtract those two, we get what? 500. And if we put that in the denominator here, we still have the same numerator. So this was what? 50 over 50. No, 50 over 500. So it's 1/10, right? 0.1 instead of 10. Is that right? Yeah. Yeah. Okay? So it depends on the units, right? And we don't want that. So we have to figure out a way to fix that. So what they do, is they talk about the relative change in the quantity relative to the total quantity and the relative change in the price. And if you do it that way, it won't depend on the units. Okay, so, and how do I get the relative change? I take delta Q divided by Q. That's the relative change in the quantity. And how do I get the relative change in the price? I do that. That's the relative change in quantity divided by the relative change in price. And now let's see. Suppose let's do it both ways, dollars and pennies, and see if we get the same number. So if we do it in dollars, what do we get for this calculation? So what was this delta Q was what? 200 over the total quantity was what? 1,000. Okay, divided by delta P is what? 5 divided by the total, this one. Okay? And now let's do it in pennies. Okay, now what do we get? Still 200 divided by 1,000 over what? 500 divided by 3,000. And you'll get the same result either way, right? Okay? So now it's independent of the units. Okay? So finally, this is the final definition of elasticity. Okay, basically it's just delta Q over delta P, but we don't like that it's negative, so we put a negative sign inside. We don't want it to be dependent on units, so we do this. Okay? And if you rewrite this, you can rewrite it like this, right? What do I put here? What do I put here? What goes on top? P. Q. Right? Algebra. Right? That's right. Okay? So that's the definition of elasticity. Okay? Now I don't see any notion of, elasticity in there. I see just the response to pulling. That's all. I don't see the coming back. So I don't see why they use the word elasticity. And the reason I make a big deal out of it is because I spent a long time, saying, oh, what does elasticity mean? And the word elasticity, what does it mean? And how does it relate? And it doesn't relate. So, anyway, so does everyone get it? This is called the elasticity. Okay? So let's look at some problems. Actually, let's look at the text. Let's look at his discussion. Oh, I forgot something, by the way. Then we define we're also going to talk about the word elastic and inelastic. So we're going to give it a mathematical cutoff point. So depending on what calculation you get here, this is E, elasticity, depending on what number you get, we're going to call the demand either elastic or inelastic. We're going to make a cutoff. Okay? All right, so we'll see what that's going to be in a few minutes. Okay? So like say, what numbers did we get here? We got, what did we get here, by the way? What do we get here? We didn't calculate, or here. What do we get here? We get, let's do it this way. So we get 200 over 5, which is 40. And then we get what? P is what? 30, so what did we just say? We got 40 times P was what? 30 over 1,000. Right? Is that right? Did I do that right? Is that right or wrong? 40 times 30 over 1,000. Yeah, that's right. Okay? So, is this number greater than 1 or less than 1? It's greater than 1, right? Does everybody agree with that? So this is going to be called elastic. But there's a reason for it to be called elastic. It's not just arbitrary. If it's greater than 1, it's one way, and if it's less than 1, it's the other. But there's a reason why they choose 1 as a cutoff point. Okay, but if it's greater than 1, it's called elastic, and if it's less than 1, it's called inelastic. Now, what does that mean in terms of the slope? Which one is going to be, where is it going to be elastic? Up here or down here? Where is it more likely to be elastic? Up here or down here? No. Up here. Because that means you're getting a greater change in the quantity for the same change in price. Okay? So up here, it's more likely. Okay, whoever is talking, next time, I'll ask you to sit here. Okay? Okay, so here it's going to be more elastic than here. Okay? Means you get more response for a change in price. Okay, does this make sense? But there's a reason they choose 1 as the cutoff point. It has some real meaning. 1 does. And we'll see that in the text. So, one more thing before we get into the text. Suppose you're marketing, suppose you're a sales manager. Suppose you're a sales manager. So sales manager has to set the price of the goods. Okay, so like you're selling coffee, you have to decide how much how much you should sell it for. Now, what happens if you have very elastic demand, like up here? So what's the significance of that for the sales manager? So if the sales manager increases the price by a little bit, what's going to happen to the demand? It's going to drop a lot, right? So if the demand is very elastic, what's the rule for the sales manager? Don't increase the price, right? Does that make sense? Because if you do, you're going to lose a lot of demand, and probably you're going to lose revenue, right? Now, you might not lose revenue though, right? If the price is increased enough relative to the drop, then you might not lose revenue, right? You might gain revenue. In fact, that's the whole point of raising the price, right? Is you think that you're going to gain revenue, right? But if you lose too much demand, then you blew it, right? You messed up, right? But what about over here? Here it's not so elastic, which means what? If you increase the price by a little bit, the demand won't change very much, in which case you're probably going to gain revenue, right? Right? So what's the rule, again, for the sales manager. If it's not elastic, if it has low elasticity, right, then what? Then it might be good to increase the price. Why? Because the demand might not drop so much, in which case you're probably going to increase your revenue. Right? Everyone understand that? Okay? And on the other hand, I guess we could say what? If the elasticity is high, it might be good to do what? Instead of increasing the price, it might be beneficial to do what? Decrease the price. Why? Well, when you decrease the price, you might lose revenue, right? But if you gain a lot of demand, then what? You probably won't decrease revenue, right? You'll probably increase. So I'm not sure about this, but maybe that's what they say in your business classes, that if you have very elastic, then it might be good to decrease the price. On the other hand, here, if you have low elasticity and you decrease the price, we said that it would be good to increase the price, and if you decrease the price, then what? You're going to lose price, but you're not going to gain much revenue. Oh, sorry, much demand. So your revenue is probably going to decrease. And that's that number 1. Turns out that when the elasticity is greater than 1, when you increase, it's just the opposite. We just discovered that it's exactly the opposite for decreasing, right? The rules are just the opposite. When it's high elasticity, if you increase versus decrease, they're just opposite situation. So anyway, the reason that number 1 is defined as 1, the reason why you use 1 as the cutoff, is they're talking about when you move forward with the price. When you move this way with the price, when it's elastic, you will, what? Decrease your revenue. When it's over here, you will increase. And it turns out the elasticity at 1 is the cutoff point for whether or not you will increase your revenue. So if the elasticity is greater than 1, you will lose revenue. Big elasticity means you'll lose revenue if you increase. And small elasticity, less than 1, means you'll gain revenue if you increase. Okay? But it's all of that is based on moving forward, because if you move to backwards, it's just the opposite. Okay? Everyone get that? Okay. So let's look at the book, what they say, because we might have forgotten something. Okay, so let's take a look at this. You manufacture an extremely popular brand of sneakers, and you want to know what will happen if you increase the selling price. Okay, so we're going to talk about increasing the selling price. So common sense tells you that demand will drop as you raise the price. The demand, not the revenue. The demand will drop. But will the drop in demand be enough to cause your revenue to fall, right? That's what we've been talking about. Or will it be small enough that the revenue will rise because of the higher selling price? For example, if you raise the price by 1%, okay, we raise the price by 1%. Now they're using percent here, remember, and we also decided to talk about relative change in price. Okay, so if you raise the price by 1%, you might suffer only a 0.5 loss in sales. That's less than 1%, right? There's a point there, right? Okay, so you get how much loss in sales? Now remember, we're talking about percentage here, right? So 0.5% loss in sales. But what is the definition of revenue? What's the definition of revenue? revenue equals price times quantity, right? So if your price increases by how much? 1%, and if your demand didn't decrease at all, then your revenue would increase by 1%, right? But they're saying, but that doesn't usually happen, right? When you increase the price, the demand will decrease. So if you increase this by 1% and decrease, and this decreases only by 0.5%, then what happens to your revenue? Let me say it again. Suppose the demand doesn't change no matter what you do to the price. So if you increase the price by 1%, then you'll get an increase in revenue, right? But we know that doesn't happen in reality, right? When you increase the price, the demand decreases. So suppose we increase this by 1% and we get a 0.5% decrease in this. What happens to the revenue? It increases, right? It still increases, right? And that's what they're saying. So they said, if you raise the price by 1% and you only suffer a 0.5% loss in sales, in this case, the loss in sales will be more than offset by the increase in the price, and your revenue will rise. Okay, so that's good. In such a case, we say the demand is inelastic. Remember we said, when are we going to increase our revenue? Down here, right? When we move this way, we don't get much of a drop, so we'll increase our revenue. This is called inelastic here. That's what we said that already. So, and that's what they're confirming here. Okay? So, in such a case, we say the demand is inelastic. So, what's the rule? If it's inelastic and you move the price forward, you'll get more revenue. Okay? So you have to kind of remember that, or you could just figure it out step by step. But, okay? On the other hand, if your 1% price increase results in a 2% drop in demand, instead of what we said before, which is only a 0.5% drop in demand, then raising the price will cause a drop in revenue. Okay? In that case, we say the demand is elastic. Okay? So where's the cutoff point? When they're both the same. Right? When you get the same increase in price as you get decrease in demand. So that's 1. So 1 is the cutoff. So if it's greater than 1, then the demand is elastic, and what happens? You'll lose revenue, right? So if it's greater than 1, you lose revenue, and we call it elastic. Okay? It's a little confusing, right? Okay? And if it's less than 1, then you'll gain money, and we call it inelastic. Okay? So it all makes sense, but you have to kind of remember it. Okay? So I guess you just have to commit it to memory, as they say. Okay, any questions about that? So we've kind of done it. We've talked about elasticity. That's kind of the whole story. Okay? And what is this called again? It's called the price elasticity of demand, because we're changing the price. What's it called in Japanese? Juyo no kakaku danryokusei, if Google is right.
需要の価格弾力性需要の価格弾力性
Okay. Alright, so what is that again in English? Price elasticity of demand. And how do we calculate it? We calculate it, here's what we said, right there. Right? Isn't that what we just finished saying? What is it? Why is the minus sign there? To make it positive. Delta Q over delta P, change in quantity for change in price. And why is this stuff here? To get rid of the dependence on the units. Right? Okay, but there's one more step. He says, he asks this question and answer here. He asks this question, he says, what small change in P should we use to do the calculation? So what's the answer? What small change in P should we use? Because we could do different changes in P. Let's look at that. Okay. If we do this one from here to here, we're going to get a certain number, right? Right? We're going to get a change here. That's this change, and this change. We're going to get some number, right? So that's if we start at 10 and go to 15. But how if we start at 10 and go to 11? It's not going to be the same number, is it? No, it's not going to be the same. Oh, the only time it would be the same number is if we had a straight line. But it's not a straight line, so it's not going to be the same number. So that means what number should we use? How big a change in P should we use? Well, there's no answer to that really. But we could define it. We could say, always use a 1% change in P, or something like that. But that's not how we do it. So how do you think we have to actually change this one more time. How do you think we're going to change this? So really what I'm saying is, if we use 10 and 15, that is a change of 5, we'd be calculating the slope of this line, right? Right? But if we use 10 and 14, we'd be calculating the slope of what? This line. Right? And if we use 10 and 11, we'd be calculating the slope of a different line. So what are we going to do? What's this subject that we've been studying for the last 8 weeks called? Derivatives, and well, we also did integrals, so it's not just derivatives, but what's the whole thing? Derivatives and integrals is called what in English? Calculus. Called calculus. Okay, so we've been studying calculus, so that's a hint to my question. What are we going to do here? Are we going to use 5? That is, are we going to use this slope? Or are we going to use 14? So we're going to use this slope, or we're going to use $1. So we're going to use this slope. What are we going to use? What? The derivative, and therefore what slope? The slope of the tangent line. Right? So instead of this slope, or whatever slope, we're going to use what? The slope of the tangent line, right? And that means we're going to use the derivative, right? So instead of delta Q over delta P, finally we're going to use, it's going to be dQ dP, which means what? That means the derivative of this curve, right? This is P, this is Q as a function of P, Q as a function of P. So the derivative would be dq dp, just like if this was y and x, it would be dy dx, right? So it's dp dq, that's the slope of that line. And then we do minus and p over q. And that's actually what we use for the elasticity, okay? So, how do you say it in Japanese?
需要の価格弾力性
So he says, what small change in price will we use for delta P? He said, it probably should be pretty small. If we say we increase the price of sneakers to $1 million per pair, the sales would likely drop to zero, but knowing this tells us nothing about how the market would respond to a modest increase in price. So it's not very informative, right? We don't do things that are not informative because we're trying to get information, trying to understand things. In fact, we'll do the usual thing we do in calculus. We'll let delta P approach zero, which means we're going to do the derivative. So here's the actual formula. Okay? Is that all right with everybody? And here's the, when do we say it's elastic versus inelastic? Elastic is greater than 1, inelastic is less than 1. But when it's elastic and you increase the price, what happens? What are the financial consequences? You lose revenue. When it's inelastic and you increase the price, you gain revenue. But on the other hand, just the opposite if you decrease the price, right? Right? Okay. Okay, good. Okay, so they do an example. Suppose the demand equation is this. So this is the demand curve. Okay, by the way, is this a straight line? Yes. There's no square here, is there? Not p squared or something like that, so it's a straight line, right? So that makes it pretty simple, right? So this is a straight line. And then they ask you, they say, find the elasticity. No. What do they do? Wait, something's wrong. They calculate the elasticity here. Why is that? Something's wrong. Let's check it. So here's the formula for the elasticity. We have to calculate the derivative of this, which is minus 2, right? The derivative is minus 2. And then times p, times q, times p over q, right? Right. So p, and then this is p, q, but they rewrote it in terms of p, right? So we get this, we multiply this out, we get this. They say when p is 2,000, we get a particular demand, and when p is 8,000, we get a particular elasticity. Here we get a different one, and here we get a different one. Okay, something strange, but I'll just keep going for a minute. Okay, this is just another example. And, okay, let's see. A bit confused here. Okay, I think I must have made a mistake. Okay, somehow I made a mistake because, kind of a big mistake. Because, what kind of curve is this? It's a straight line, right? So what I said was wrong. Well, I said that if it's a straight line, the elasticity is the same everywhere. Right? Didn't I say that about 10 times? Yeah, I said it about 10 times. But it's not. Look, when p equals 2,000, the elasticity is 1/4. When p equals 8,000, the elasticity is 4. So I was definitely completely wrong. Did everyone see? Right? This is a straight line. Right? I'm not wrong now, am I? This is a straight line. But at different times we have different elasticities. Right? Can anybody explain why I was wrong?
If it was straight and it was like in the right angle to the curve, then it would have been the same everywhere. But if the straight line is a bit like this or this,
No, I don't think that's it. I hope not. I don't think that's it. Anybody else have an idea? Yeah.
So in elasticity.
What?
In elasticity.
Yeah.
There's a concept called point elasticity. In that case, you find the elasticity at each point, not the whole.
Yeah, but they did it here at a particular point.
Yeah. So if you do that like that,
Mm.
the elasticity differs from point to point.
Yeah, but I can see that because that's what happened here. But what I'm saying is I said the wrong thing. And what did I say?
The whole the slope is equal.
I said if it's a straight line, then the elasticity is going to be the same everywhere, right? But that's what I said, right? But this is a straight line, right? But the elasticity is obviously not the same everywhere. So but why did I say that it's going to be the same everywhere? Why did I say that? Because I said it's the derivative, right? Right? I said it was dq dp, right? Or delta q over delta p, right? Which is the slope, which is the same everywhere, right? So what did I do wrong? I forgot this. It's not just this. It's this. Right? And that's going to change things, I guess. Because, so this is, let's see, this one looks like something like that, right? It's negative. Slope is like that. Or Q versus P. Okay? Now let's think about it. Here versus here. When you're out here, what happens? First of all, what happens here? In the actual example, when you go out to 8,000, what happens? E is big, and when you're at 2,000, E is small, right? Right, so E here is equal to what? Is equal to 1/4, and here is equal to what? 4. So why is that if it's a straight line is what we have to figure out. And I think it's as I said, because it's not just this, it's this. So what's going on? It's P over Q. So P over Q here versus here, what's the difference? Here versus here, what's the difference? So here we have a what? A big P. First of all, it's P over Q that we're thinking of, that we're considering, right? P over Q. So over here, P is what? P is big, and Q is small. right? Whereas over here, it's opposite, right? So big, small makes this big. So when you move out, because of the P over the Q, even though it's a straight line, it's not going to be the same elasticity. Right? Okay? So forget what I said about straight line always has the same elasticity. Straight line always has the same slope, but elasticity, now we made it relative, and so it's not the same anymore. Okay? Okay. Sorry about that. But at least we can say that. Okay, now we are generally interested in the price that maximizes revenue. And in ordinary cases, the price that maximizes revenue must give unit elasticity. Wow. One way of seeing this is follow. I'm not going to do that. You can read this on your own. He says here, though, that the place where you're going to maximize revenue is when the elasticity is 1. I'll let you read that. Okay, he says one way of seeing that is as follows. Okay, so I don't want to read that. Okay? And now he does price elasticity of demand for dolls. So he does this. Gets the calculation. Does the calculations. Finally, I don't know, get some number. Okay, let's do one more thing here. And this is called, this is different. First of all, what are these? Porsche. What's a Porsche? It's a car, right? And it's an expensive car, luxury car, right? Super fast sports car, right? Okay, now, but it's also a commodity, right? So we can talk about the elasticity of the price elasticity of the demand for Porsches, right? We could talk about that, right? So if you increase the price, what happens to the demand, right? We could ask that. But that's not what they're asking here. This is a little different question. They're saying, if you look at different people's incomes, and then you look at their propensity to buy a Porsche, or the chance that they will buy a Porsche. So what can we say? Of course, richer people, people that have higher incomes, should have a higher chance of purchasing a Porsche. Doesn't mean that if you're rich, you're definitely going to purchase a Porsche, right? You might not. You might purchase a Maserati, or a Rolls Royce, or a Mercedes, or something, right? You don't have to. But anyway, the chances of purchasing a Porsche will go up if you're richer. That seems to make sense, right? So, that's what they're talking about here. What's it called? Not the price elasticity of demand, not what happens if we increase the price, but what happens to the chance of purchase. That's what they mean by demand here. It's different, right? It's not really the same thing as we meant by demand before. But what happens to the chance of purchasing if what? You consider people with more income. Okay? And obviously it should go up, but the question is, how much does it go up? Okay, does everyone get this question? So let's look at it here first. How do you say that? Somebody said this should be Kyuryo, but Kyuryo I think is salary, which is a little different than income. Anyway, they translate it here as what? Juyo was, I think, wasn't that the demand?
Yeah.
So the income is what? Shotoku. Shotoku. To shotoku. So juyo no shotoku danryoku sei.
需要の所得弾力性。需要の所得弾力性。需要の所得弾力性。
So that's what we're talking about here. The income elasticity of demand. So now we need still a so-called demand curve. Now normally the demand curve relates what two variables? Normally a demand curve relates what two variables? Price and quantity. So it's not really a demand curve in the traditional sense, but this demand curve is going to relate what two quantities? Income and what? And quantity, right. Okay, so it's really different. But anyway, they still call it elasticity of demand, income elasticity of demand. Okay, so they say, you are the sales director at Suburban Porsche. And you've noticed that demand for Porsches depends on income. Not only did you notice that, but you actually have a relationship or a formula for as X increases, X being the price, what happens to the quantity demanded? So you have this wild formula. Let's look at it. Can you see that? Okay, you came up with this wild formula. It has E in it. Okay? So who knows where they came up with this? Okay, but supposedly this is the demand versus income. So X is income, right? And Q is, okay. So here X is the income of the potential customer in hundreds of thousands of dollars. So X equals 1 means how many, what's their income? $100,000. X equals 10 means what's their income? $1 million. Okay? So X is between 1 and 10. Here X is the income of a customer in hundreds of thousands of dollars. And Q is the probability, not the quantity. Okay, so we made a mistake. Q is not the quantity, actually. It's the probability that a person will purchase a Porsche. So can Q ever be bigger than 1? If Q was quantity, we hope it's bigger than 1, right? Because the quantity, you want to sell more than one Porsche, right? Right? But they didn't. But Q is not the quantity. We made a mistake. Q is what? What's it say? Q is the what? Probability. So can Q ever be bigger than 1? This is maybe for those of you who haven't studied statistics, you might have not thought about this much, but can Q be bigger than 1? No, you don't say the probability is 125% that somebody's going to buy a Porsche, right? Right? You might say it's 80% or 95% or 30%, but you never say it's more than 1. Right? So Q is not going to be bigger than 1. So this number here better never be bigger than 1, otherwise something's wrong. We won't bother to check that, but I'm sure that it never gets bigger than 1, because this is the probability. Okay? Now, they're going to define something called the income elasticity of demand. So this is like not nearly as much used in economics as the other thing that we just finished studying, price elasticity, but we can still talk about this. Okay, this is the income elasticity of demand. And notice that they did not put a negative sign here for this one. Okay? That's because, what's this curve look like? Is it a decreasing curve or an increasing curve? As people's income increases, what happens to the chance that they're going to buy a Porsche? It's going to increase. So this is already an increasing curve, So there's no reason to put the negative sign in front. So they don't do that. Okay? The rest of it is the same, basically. Okay? So we get that, and then we get some calculations. Okay, so we won't go through those, but dq, dx, you should know how to do that. You have to take the derivative of this wild function here, this wild function. How do you do that? What rule do you need to find the derivative? Because we want to do this income elasticity, that means we're going to have to take the derivative of this. So, how are we going to take the derivative of this? What rule do we need? Not the power rule. It's not the power rule. What rule? Everybody? Chain rule. Right? We need the chain rule here. What's the chain rule? In the chain rule, they always talk about the outside function and the inside function. What's the inside function here? This is the inside function, right? Minus 0.05x squared plus x is the inside function. What's the outside function? Raising something to the e, and I guess multiplying by a constant. Okay? So you need the chain rule to do the derivative, and then you have to multiply by x over q, and you can do all of that. And finally you'll get that the elasticity when x equals 2, what does x equals 2 stand for again? The income is what? $200,000. When the income is $200,000, the elasticity is this, okay? And here, when x is 900,000, the elasticity is here. So what does this mean? Thus, at an income level of $900,000, the probability that a customer will purchase a Porsche increases at a rate of 0.9% per 1% increase in income. Okay. All right? So, next time I teach this, I won't make the mistake of saying, what? I won't make the mistake of saying what? That if the demand curve is what? A straight line, that means that the elasticity is the same everywhere. Right? So don't make that mistake yourself. Okay, because it's not true, right? We saw that example where it wasn't true. Okay? So, and why is that? If it was just the derivative, it would be true, but we take out the units, and when we do that, we get different calculations. Okay? Okay. Any questions? Does anybody have any questions about the final exam? Either content questions or questions about the format or anything?
What is the content
Oh.
for the exam?
What is the content? You want me to mail you the exam?
Yeah.
Okay, I'll do that after the exam. Yeah. But, there are 14 questions, but they have different parts. So it could be a total of like 25 or 30 different answers that you have to provide. But there's 14 questions. And as I said already, there's one on elasticity, there's one here, 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 there's nothing for this one. No min and max part 1. No implicit differentiation. I think there's one here, one here, one here, maybe one here. Marginal plus, I think there's one there. Then we skip most of this. And log logarithmic, exponential, and quadratic models, yes. And simple, compound, and annuities. Simple interest, compound interest, and annuities. So that's the contents of the exam. And usually, as I said, what I do is I just copy the problem from, I go to the homework, like here, Elasticity, and I find a problem like this, and I copy it, and I paste it in, okay? And then you have to provide the answer, okay? Which in this case is this. So, oh, that was an Elasticity, wasn't it? What's this one? Okay, and generally speaking, I go for the problems at the beginning of the homework section. So like these first 5, I might choose one from there, as opposed to these. But I did say for one particular homework section, one particular homework, I think it was this one, I didn't limit myself to just the beginning. This one, indefinite integrals. I didn't limit myself just the beginning for that one. There's some word problems here. Yeah. Okay? So, as I said, they're from here. I just copied them from there. Any other questions? And the videos are available, and even some I didn't mention that we recorded, but I didn't send you an email about it. But they're all under that same account. So if you can find, the 3 of them, you can find all of them. You just check the account in YouTube, and they'll all be under that same account. Okay? So you should be able to find all of them. Any other questions? Okay.
Can you please say the contents again?
Sorry? Contents I just told you.
Right, it's too fast.
No, anyway, I said it's everything except for here. If you look at communication, here I said reduction in material needed to study. So it's everything except for these. Okay? I said that already. Okay? So it's everything except for these. And there's actually a few more that I forgot to mention, and those are here. So also, you don't need to study these 2. This one, implicit differentiation, you don't need to study it. And this one just next to it, max and min part 1, you don't need. Okay? So those 2 in addition to the list. Okay, any other questions? She's willing to stick her neck out and ask questions, you're lucky. Anybody else willing to stick your neck out and ask questions? Yes? Is there what? Yeah. So this one, yes. But this one, no. And the one above it, implicit differentiation, no. Any other questions? No? Okay, then we can leave. Let's see. So it's on the 29th, which is Tuesday, same day, a week from today.